Good morning. So this morning we're going to cover proxy charms. Anyone has experience with proxy charms? Okay, that's good. So we'll have around 2.5 hours with proxy charms. Regular proxy charms. This is a method for configuring the VNF, directly logging into the VNF from OSM and running some automated scripts. And traditionally it works over SSH. But next, we will, after this introduction with traditional proxy charms, we will have Ansible-based proxy charms later today. And tomorrow, you will hear about native charms, which is a charm running closer to the VNF. So these proxy charms, they run from OSM to configure the VNF. So you will understand more while I progress with the presentation. Okay, first of all, what is a charm? A charm basically is a piece of software that runs scripts over some target. Traditionally, the charms, which are brought by a software called UU, which is an open source, they are used inside an application or in the same machine as an application. That's why we call charms regularly native charms, because the regular ones outside the scope of OSM, they run in the same machine as the application, doing stuff like running scripts, connecting applications between each other. For example, providing an application, WordPress, for example, providing and installing another application, MySQL, for example, and then connecting both. So MySQL provides a MySQL interface, WordPress requires a MySQL interface, and then you have what we call in the UU context relations. Okay, but so this is outside the scope of OSM. UU is widely used with charms to deploy applications and build relationships between each other. So since there's that functionality, and when OSM started, Canonical was one of the founders, and they decided that the project founders decided to use this mechanism for configuring VNFs. So it's sort of our generic VNF manager, if you want. So, well, this is all implemented by UU, which is an open source modeling tool, as it says here, which is built from a controller, models, and charms. So you, by default, have a controller, where you communicate with a controller. And the controller builds models, which are instances of this controller, and which deploy the charms, which is finally the pieces of software that will, as I said before, deploy applications, connect applications between each other, configure the application, etc. So it handles configuration of applications, relationships between applications, the life cycle. It can start an application, kill an application, and a scaling of an application. Okay? So this is sort of how things are working in UU. You have a client, which is a CLI, or in OSM you will have only a CLI, but in UU, outside the scope of OSM, it has also a GUI. You communicate with a controller which has a database, basically, and it builds charms inside models, which are like private instances for running charms. And the charms, finally, are the pieces of software that deploy and interconnect applications. So proxy charms. Proxy charms is a concept that was born basically in OSM. Why? Because traditionally, charms run inside a VNF or a VM, or where application runs. But in the context of NFV, it's more difficult, but it's getting easier today, but years ago, it was more difficult to even think about having a piece of software installed in a VNF, right? VNF providers here would agree that if an NFV orchestrator requires you to install a software or an agent or something in your VNF, you are probably not agree because it's a piece of software that is not part of your VNF. Right? So, given that, the concept of proxy charms was created. So the charms run in open source Mano, in LXC container, something. And they connect to the application remotely. The application, the VNFs, run in NFVI, most probably managed by OpenStack, and expose a management network. So open source Mano connects through implements proxy charms, and proxy charms connect through SSH to a management VM of the VNF and configures the VNF. Okay, this is what will happen at the end. Is it clear? The purpose is configuring it beyond instantiation, because in OSM, so far you have seen how to instantiate VMs. No? That's just seeing the VMs running, but you can do that with OpenStack, right? Or a generic orchestrator like Heat. You can do that, right? But the value that this adds, as any generic DNF manager, is connecting to the VMs and configuring it. For example, you mentioned the load balancer. With this, you can potentially, whenever you scale your VNF, you can go to a load balancer dynamically and add the member. It's a VNF manager. It's the VNF manager of open source Mano. So it takes care of day 1 and day 2 primitives, if you want. So we will talk more about day 0, day 1, day 2. But basically, day 0 is all about getting your application or your VNF ready for management. So you instantiate and you make it, you put an IP address and maybe credentials so that you are able to manage it. That's day 0. That's what we could call day 0. But your application is not configured by default. I mean, it can have an image, but maybe it's not ready for providing services. Maybe you have to start a process, or you need to adapt the configuration to the environment. So that's when day 1 kicks in. Day 1 takes care of the initial configuration of your VNF so that it's ready for providing a service. And we use proxy charms for that. So if you are a VNF provider, you would build your package and you would have a set of scripts included in your proxy charm, which will run automatically as soon as the instantiation is done, and will configure your application in whatever way you want. Through SSH, which is the default method that proxy charms provide, or through other methods that we are starting to add, for example, like Ansible playbooks or a REST API, basically those, or maybe netconf in the future. So with proxy charms, you can build whatever you want because it's just a piece of code, Python. You can't do anything. I think you can. You could. What do you say, David? Be reachable. Yeah. So today, even with native charms, the controller lives in OSM. So the controller needs to access the native charms. So you need a management network between OSM and the VNFs. But we're working in a feature where you will have distributed controllers, let's say. Okay. Yeah. So in that case, when we will have distributed controllers of UU, which we call VCA in the context of OSM, is VNF configuration and abstraction. You will have distributed VCAs, and OSM doesn't need to connect directly to the VNFs. It does it through the distributed VCAs that live in the edge, for example, where you could potentially have the VNF. That's a use case. Any other questions so far? Okay. So, as I was saying before, VNF configuration or VNF onboarding in general in NFV is all about taking care of these days which describe the state of the VNF in its life cycle. So regular orchestrators which live at the NFVI level, like OpenStack heap, for example, usually go up to day 0. So you instantiate the VNF or the VMs that are that provide the VNF, and the machine gets ready to be managed. So you import SSH keys, create user and passwords, provide a network configuration, so that you make this machine reachable from your manager, and it's ready to be configured. Next, you have day 1. So in day 1, which should run automatically, the machine gets configured to provide the services, the actual services. So, for example, a P gateway would be configured to initiate the process, the internal processes to raise the different access and core interfaces, or a web server will start running the web service and maybe configure some users, some initial pages, anything that would get the machine ready for providing the service that the network function should provide. Then you have day 2. Day 2 happens after the VNF has been instantiated, configured, and is already in production, let's say. It's already providing services. So you can run on-demand actions. Like, for example, add more users, scale the VNF, add more subscribers, configure security rules, and whatever occurs in the day-to-day operation. So that needs to occur on demand, right? So all of these days should be, OSM should be able to manage them from the VNF manager. Day 0 usually is covered with Cloud Init, because you can put there some scripts to pre-configure the image, to import some SSH keys, or to use certain credentials, to modify certain files. But day 1, day 2 require usually more complex scripting, and that's why we use a different mechanism for that, which in the case of OSM is proxy channels. Any question? Give me an example, please. Give me an example of managing a VNF with an SDN controller.
You can instantiate the VNF,
Mm-hmm.
and you provide policies and policy-based management with SDN controller. You can configure it.
Yeah, for example, you have a packet core, okay? Ericsson, Nokia, whatever. It has a set of VMs, let's say 30 VMs that needs to be touched, needs to be configured, and it has its own manager. And that exposes a REST API if you want to configure the packet core. So in that case, how would you handle that with an SDN controller? SDN controller takes care of networking, maybe. Takes care of policies for the networking devices that are compatible with the SDN controller. But here you're dealing with a big marketplace, let's say, or amount of different DNFs that expose different APIs, or maybe no API, just CLI, a proprietary CLI. So SDN controllers would not necessarily be compatible with all these cases. And so you need a mechanism, like a generic DNF manager, in NFV terminology, to adapt to any API that the DNF exposes so that you can configure it. And you need to be agnostic, because in NFV we're trying to build a cloud that is operated by the service provider, not by the vendors of the DNFs, where different DNF vendors will be instantiated there, configured there, and you need a neutral piece of software that can configure anything. No? It can coexist, definitely. I mean, in the... Sorry? Independent from what? Yeah, of course. I mean, SDN controllers are used for creating the networking part. Not SDN, you wouldn't use an SDN controller, for example, to add subscribers to an HSS in the mobile packet core, or to add firewall rules in a Fortinet firewall, for example. You wouldn't use an SDN controller for that. SDN controller, it belongs in the NFV world to the BIM layer, to the NFVI. In the NFVI, you have the hypervisor, you have the virtual networks, and the virtual storage. Right? So who takes care of the virtual networking? That's the SDN controller. Some of you may say, but OpenStack takes care of that. Yeah, but OpenStack includes an SDN controller, which is included in Neutron, which is real, actually, an SDN controller, right? You have an outbound interface? Sorry?
Then you have a northbound APIs for configuring VNF application in SDN architecture.
But it's not generic enough. I mean, you have another one API, for example, in the SDN controller, which will provide virtual networking for you, just networking. So you can interconnect your DNFs physically or virtually by using an SDN controller. For example, Neutron provides virtual networking. Maybe ONOS can provide underlay networking between your DNFs. So it will go to switches and configure them. Maybe Cisco ACI will provide even wider configurations to your switches and maybe even to your VMs. But then you need someone to know the concept of VNF and interact with the VNF's API to go and configure the application that runs inside the VNF. That's not the role of an SDN controller.
But that can be done with the northbound API and SDN architecture.
So
could be used to configure VNF applications on northbound APIs.
So when you talk about SDN architecture, what are your components that your SDN architecture includes?
So first you have a lower layer abstraction, which is from layer 3 and below, and then you have from layer 4 to 7 is just northbound APIs.
Okay.
So my question is that, for instance, you have a VNF's application via northbound APIs, and then you have a network through, let's say, on the lower level abstraction, you use OpenFlow or other protocols. So it kinds of a whole package for configuring VNF's application on SDN architecture. So my question is, why, if you're using a Juju, is it independent, or we can also configure it via SDN?
Juju is the software runs inside OSM. So only OSM is consuming the API of Juju, which will at the same time go to any VNF. Okay, we can keep talking about this, but I think that you're mixing layers, because the SDN controller itself would take care of the networking part, and the higher layer, that management and orchestration, will take care of the VNF lifecycle. But we can talk more about this later. Okay. So proxy charms in general provide layers, so that you can build a proxy charm, and if a layer is, a piece of software is common for many charms, then you can reuse it. And that's why layers are used. So there are many layers that you can use. There is a VNF proxy layer that includes ways to connect automatically to any VNF through SSH. There is an Ansible layer that you will see later that will allow you to build playbooks on top of it. So, and then you can create your own layer, and that's the idea. For example, you have a VNF that is a firewall, okay? And it's configured with a proprietary CLI of yours. And you want OSM to automatically take care of day 1 and day 2 operations. So you build a proxy charm that is based on SSH, for example. That's already taken care by a layer VNF proxy. And you build your own actions that run your own commands. Let's say firewall CLI add rule X. And that's your layer. And then anyone that uses your firewall will implement proxy charms using the layer you built. Okay. So at the end, day 1, for example, will be open source Mano takes care of instantiating the VNF through RO, for example, which is a resource orchestrator. And then the proxy charm is used to get inside the VNF and configure it and install it. So in day 1, you probably need some software installation and configuration. This is just an example. This is installing MySQL. And then it starts providing the service. So MySQL is started at port 3306, and it starts receiving some queries to have information about subscribers, for example. That's happening in day 1. In day 2, the service is already running, and maybe you want to run daily backups. So you have a proxy charm that connects every day and takes a backup from your VNF. So that's a very basic example of how different operations would look like in day 1 and day 2. Okay. So, how would you build your charm? You need to use some extra software in your own OSM machine or elsewhere to build this piece of software. And at the end, you need to create these charms and include it somewhere so that you make it part of your VNF. That location is the VNF package. In the VNF package, you will have a charms folder that includes all these scripts you prepared, so that whenever you instantiate your VNF from open source Mano, it automatically gets instantiated, and then charms are run over these VNFs. So at the end, let's see the big picture, okay? What you're building here is a package that is automatically instantiated, configured, and operated after you. It's not only taking care of instantiation. That's what I mean. So if you are a VNF provider and you build your package, including the charms you need for day 1 and day 2, that package can be reused anywhere, in any service provider, in any network. That's single package. Imagine that you can even parameterize some of your scripts or configurations so that you make it agnostic to the infrastructure. So that's the final idea. So you have a single VNF package that will work in any NFV environment. OSM would help with abstracting you from the complexities of any environment, because OSM will work with VMware, will work with OpenStack, even with Amazon Web Services. And as long as you have the VNF modeled with OSM's information model, then it would look the same regardless of the infrastructure that OSM is managing below. Okay, so that's the idea, to have a package that includes charms that will configure automatically the VNF after it's instantiated, and you will be able to operate it because it will expose some methods for you to do that. Okay, so wherever you install whenever you will build your charms, you will need to install a piece of software. It's called charm. And then you create some directories. Well, you will prepare the different software you will build. And for convenience, you map some of the environment variables to those directories. So at the end, important part, you create your charm, charm create, and the name of the charm. Okay. And you have to edit some files for the charm to work. For example, the metadata file, which contains information about who built the software and what it does. You have a layer charm which includes, the layer file, which includes which layers you are going to reuse. So here, for example, we are going to reuse the basic layer, which provides the basic functionality of charms, and the VNF proxy layer, which provides automatically connection to the SSH, through SSH to any VNF. And potentially you can use other layers like Ansible, for example, which we will see later. Then you have the actions. What actions do you want to implement with your charm? For example, you want to upgrade your charm eventually, or you want to initialize your VNF. That could be a day one action. You can build your action, name them whatever you want with the variables that you want. For example, here, this is a very simple example that you will test yourself. But this is the touch action. It runs a touch command, a Linux command that creates a file. And you provide as a parameter the file name. That's it. So it will go to a VNF and create a file. A very, very simple use case. And it requires the name of the parameter. I mean, that's a mandatory parameter. Then, this is a reactive file that you will see. We will need to add some dependencies there that are not by default present. And you will start noticing this is the most important file where you will, this can be a single line or it can be a huge file with all the actions that your VNF support. So this is where you will do stuff with your VNF. For example, by default it will include this function, you can say, that will say that as soon as the software that the charm needs to run is installed, it will put the VNF or the proxy charm in active status. But then you need to create some files associated to the action that you designed in the actions YAML file. So previously we saw that we created this action called touch. You need to create some files for that for every action and make them executable. And finally, and this is the most important part, you edit that reactive simple file that is automatically created with the actions that you want. So here is where you customize your own functions. What we're doing here, whenever the touch action, or we call it also primitive, is executed, is called, then it touches a file. It tries it gets the file name parameter, which is a data descriptor. You define it as a descriptor. Then it runs the command touch, or well, it's creating the variable named command, touch the file name, and then it actually runs the command over the VNF. So you can change these 3 lines for whatever you want. For example, in plug tests, in Etsy plug tests, we do more advanced examples, and we do things like implementing Sol2. I don't know if you're familiar with Sol2. Sol2 is the standard, the Etsy standard for configuring VNFs. It's expected to run with REST APIs. So the VNF needs to provide a server that listens in a predefined path, or expects you to provide the configuration in JSON through a predefined path. So in here, instead of these 3 lines, we put a Python requests based script that will go and insert do a post call to the VNF and insert a JSON configuration in the VNF. So you can do whatever you want here, so that whenever your VNF is launched, this script kicks in and configures your VNF with the variables you provided. Okay? Any questions so far? You will see this by yourself. It can look complicated, and it will be. But it is complicated but it's also powerful. It's flexible. You can do whatever you want here. If you're a VNF provider and you need to support, I don't know, Sol2, and also, but you want it to be configured through Ansible, and you want it to be configured also with netconf, eventually, you are thinking about OSM for orchestrating your VNF, then you can be sure that through proxy charms, you can interact with the VNF in whatever method you want, because these actions here can be implemented in any way Python supports. Okay. Okay, at the end, when you prepared all those files, you just build the charm, and it will prepare a folder for you. And then you include that folder in your VNF, and you're almost done. I'm going through all this theory for 2 reasons. One is because this is a complex topic, and I want you to get a big picture. And the other reason is that we don't have a Wi-Fi, so you can do it. Oh, it's back, okay. But the first reason was the more important. Okay, so let's go all through the end. Then I will run the example myself, and then you will run it yourself, okay, with my support. Okay, so how would you, when you prepared your charm, it's ready, but it's in your development environment, it's isolated from your VNF package. It has all the actions you need for your VNF, but you need to include it somehow in your VNF, right? So here is where you start editing your descriptors for supporting these charms, or these actions. Well, we were saying that day 0 is covered by Cloud Init, but day 1 and day 2, which are the configurations of your VNF and the operation of your VNF, is covered with proxy charms. So open source Mano, including the proxy charms, will connect with the management interface of your VNF and run these scripts. You will download an incomplete VNF package. It's just missing the charm for you to add it. Okay? And then we will uncompress it to start editing it. This is here, this is a complete one, so that you can take it as a reference and eventually copy and paste the missing parts. It will be easier that way. But what do we need to do? We need to add this new section called VNF configuration in the descriptor. Okay? This is where you start adding day 1 and day 2 primitives to your VNF. You specify the name of the charm that you implemented. Charm is called simple in our case. Then you start defining what we will call initial config primitives, and then we will define the config primitives. What do you think is the difference between initial config primitives and config primitives? Any idea? Initial config primitives suggest something. For example, yeah, day 0. Day 0 was just about making your VNF manageable. So with SSH keys and credentials, potentially users, and that's mostly covered by Cloud Init. So in the Proxy Charm world, we start with day 1. So I guess you would say day 1. Yeah. So initial config primitives would run as soon as your VNF has been instantiated. So you have the VMs. So far we are no different than OpenStack Heat. We just instantiated the VMs. But now we add value with OSM because we are configuring the VNF. We are getting inside the VNF, and we are running some scripts that are valuable for your VNF. And for that, it uses a well-known primitive called config. So this is a fixed name where you have parameters, hostname, username, password, that you would use to connect to your VNF. Of course, it's insecure to include passwords in the descriptor, but this is just for it to be simple. But if you don't include a password, it will automatically go and insert the key so that you will connect with passwords. Okay. So that's the initial config primitive that takes care of the configuration of SSH parameters that you will use, the system will use to connect to it. But the actual function that you created, remember that in the charm, we created an action that it was called touch. So you refer to that action here. Name, touch. It has to be the same name as in your charm. And the same parameter, which was called file name. And you provide the value. In that case, the default value was, let me see, inside the charm. When we created the action, it had nothing on it. Default value, blank. So then, in the descriptor, we are giving it a new value, which is home Ubuntu first touch. That's the name of the file name. Okay. Sorry. Then we implement day 2 primitives with a config primitive section in the descriptor, and we will use the same one, okay, for convenience. Just a basic use case. Name, touch, parameters, same file name, but in this case we will change the value. Okay, the default value for the config primitive will be touched, so that you can see a difference between one and the other. So this one is run on demand, and this one here is run automatically. Finally, you copy the charm you built at the beginning inside your package, inside the folder that you will package for your unit. There is a charms folder. You saw yesterday that there was a Cloud Init folder, right, where you include Cloud Init files. Now there is a charms folder where you will include charms. Then I have included in all your tenants this validate descriptor file. I think you have already used it in one of the sessions. Right? It's included in the DevOps package, but you will find it here. So you will run it like this, Python, validate descriptor, and the YAML that you created, so that take care of any potential error. And then you repackage it. We'll just run tar to recompress it. So now you have a package that includes a charm. It will be a little bit heavier, like 5 to 6 megs, but it will run automated operations as compared to the previous ones you used. Then you will download the descriptor of the network service. We will not lose time here, just download it, it's already there. And finally, we will see everything happen. So you create the VNF in the catalog of OSM, the NSD, the descriptors, the packages, and then you instantiate. But before instantiating, I was telling that these proxy charms run in containers, LXC containers. So that's because of security isolation between VNFs, for example, and keeping the packages independent from one another. You can have a VNF from one provider in a set of LXC containers, and VNF from other provider completely isolated. And also it's easier for the life cycle of these of VNFs. When you delete the VNF, all the LXC containers that were running the proxy charms are deleted as well. But this adds a level of complexity, because whenever you instantiate a VNF, it has to start a LXC container, deploy the software it needs, the image of Ubuntu image, for example, inside the LXC container, and then install the software that you need for your VNF. And that takes time, depending on your internet connection. Maybe you don't even have an internet connection in the site. So there are some ways to accelerate the deployment of these LXC containers. There's a script here that you can use that will install a local image of whatever the LXC container needs to start a proxy charm, and make sure that you don't update and upgrade that image because it has everything you need. That's one of the methods that you can use for accelerating the deployment of a charm. And the other method is that you can just let everything be installed and use a mirror that is closer to your location. Okay. But there's a small challenge here, because this used to work for any charm before release 5. But in release 6 of OSM, each network service runs its own model. It maps to a new model of UU. So you don't know what is going to be your model before you instantiate your network service. When you create a network service, it is created with a unique ID, right? It's a long number. The name of the model will be this number. So you don't know this number before you instantiate the network service. That's why you cannot apply this model configuration if your model does not exist yet. So you will understand more of this when you deal directly. But we will try this second method here, because this first one is not that predictable when we are using a shared environment. So there's not much experience yet with this first method in a shared environment like this. Shared is an OSM instance that you are sharing with RBAC. That's a new feature, so we need to enhance some things. But in the second method, we will just configure a mirror that is closer to the location of the NFBI, which is Etsy in France. But we need to do it as soon as we create the network service. You will change the Beam account with the right Beam name and use whatever name you want for your network service when instantiating. You will, the network service descriptor has a name, which is management net. You will replace that named dynamically there with the name of your actual network. That's what this command is doing. But then, okay, after you create the network service, you have an instance of your VNF. You will list that to get the, well, this is just automated. You can copy and paste the network service ID and do the same thing. But at the end, what you need to do is switch to the model with a UU switch command, UU switch and the ID of your network service, and you will be in the model that runs your proxy charms. And then you configure the model to run, to have this closer mirror. You have to do this quickly before the LXC container is instantiated. Okay, so at the end, you will instantiate. This will take care of instantiation, and you will monitor the proxy charms with UU commands, so UU status and UU debug log are the most commonly used. And finally, you will have your VNF instantiated, you will SSH to it, and you will see that it includes a password, a file name, which was automatically included by OSM. This is a very simple example, but it could be as big as you want. It can take care of all the configuration, touch a lot of files, configure with templating, Jinja. You can use playbooks, as I said. But this is a very basic example, because later you will see another more complex one, a more valuable one. Then we will test day 2, but there is just a theory, in theory here we're going to see it, because yesterday we discovered a bug in shared environments like this one. But the idea is that you can run actions either from the UI or from the CLI that will run the day 2 primitive, and you specify the network service where you will run the primitive and the name of the primitive. So it will run add another file, basically. Okay, so that's the whole idea. Don't worry, we have time to go over this again. But I hope that you grab the big picture. I mean, this will take care of the configuration of the VNF after it has been instantiated, and it can go as far as you want with any API that the VNF supports. That's the idea. Any question before I try this? No questions? Okay. So I will try this myself, like a demo, and then you will do the same. Okay? I think that's the best way to deal with this. I'm doing it because it was very hard for me at first to understand charms. So I'm trying to be empathic here. Okay, I'm going to connect to you. Oh, I need to. Can I make this default? You remember how to make this default? No, I have to do it again. Change settings.
OSM? You can start it.
To start it? Oh, okay. Yes. Okay. You will access the same machine you accessed yesterday. It's a shared environment. And we'll go through the process. So, first of all, we need to build a charm. I think I already did that, but anyway. So you need to install this package here. I think it's already there. Oops. So installed. Then you need to create these directories. In my case, the charms directory is already there. But I need to, for convenience, map this charms directory here to a variable. It's better for you to include these variables in your bash file. So there's this hidden file called, no, it's not here. There's this hidden file called bash rc. where you can include these exports so that they run automatically when you log in again. I didn't do that, so that's why I ran it again. That's the important part. Then you have this charms layer directory. And that's basically it, because the interfaces one is for UU relations, which is not supported yet. Okay, so then we will create this simple charm. I already did that, but I will erase it. Layers. Oh, it's not there. Okay, great. So charm create simple. This will create a charm. So all this directory structure, the reactive files, the actions, the metadata, all of that will be here in the simple folder. See? That's the source of your charm. Okay, so you will see that structure there. Then you will start editing the file. I will make things simple and copy and paste everything. So you have this metadata file here. It has all of this information, name, summary, maintainer. I could leave it like this, or I can add my own information. The basic things are already included in the presentation. You can add your email, your name, whatever you want. It's just information. Then you have the layer file. This is important because here we specify the pieces of software that we will reuse. And you will take care of importing them to your charm when you build it. So let's edit that file. It only has the basic layer. So I will erase that and just copy and paste this to include also the VNF proxy layer, which will take care of SSH connection to your VNF. Great. Then we have the actions file. This is where you define all the actions that you want to run, even day 1 or day 2. Doesn't matter. Because you made a difference between day 1 and day 2 in the descriptor. When you say initial config primitives are these ones, they run automatically. And on-demand day 2 primitives are these ones. There is where you make the distinction. But in your charm, they are the same thing. Okay, so the action file actually doesn't exist, so you need to create it. It's not there. Actions, YAML. So again, it's called touch, the action. I can have many actions here, as much as I want. What it does, it touches a file on the VNF. It creates a file. And it has some parameters. File name, which is the name of the file. Type is string. Default is none. So I need to provide it. Great. Then you have the reactive file. We call it a reactive file because it's in the reactive folder, but it will have actually the name of your charm. So let's go there. This is where your customized code will be. Okay. I will copy and paste this because by default this and we need to probably to do something about this. You don't have all the dependencies you want to have by default here. So I will just replace the contents, okay? So this reactive file is doing nothing. It's just, well, the layer, the VNF proxy layer, will say that SSH proxy layer, which is included, is ready. So this is, when that happens, your proxy charm will just go to active status. But this is doing nothing. Now, for the action we created, we need to add a code that is always the same. But since the Proxy charm doesn't know, or Juju doesn't know what will be the name of your action, we can't pre-create this file. But you need to create this inside the actions folder. Sorry, you need to create that folder, actions. And inside it, you need to create a file which will match the name of your of every action that you created. This is important. It needs to have the same name. And then you add the same contents to every action that you created. So this is simple. So if you created two actions, touch, upgrade, install, initialize, reconfigure, whatever, you need to add the same content. I know that this is not ideal. That's why we came up with the idea of generators of proxy charm that will do this, all of this automatically, okay? But step by step, you will see that example later in the Ansible charms session. So for now, I need you to understand that the proxy charm, the structure of proxy charms. Okay, so we have our file, and important, you need to make it executable. There you go. We're almost there. Now, this is where magic happens. This is where you can do whatever you want with your VNF. We add actions, the action, actually, that we created. We add the code that will implement the action to the reactive file, reactive simple.py. So we'll append on this file the function that we want to run. So when the action is touch, the name of the action that is run is touch, then we have a function called touch, and this will run. It will touch a file. It will get the file name from the descriptor. I mean, actually what happens is that OSM's LCM provides the variables that are included in the descriptor to VCA, I mean to the UU environment. So the charm can get those variables with this method here called ActionGet. So it will get the file name that you define as your descriptor. It will run the command touch and the file name. That's it. Very simple. But as I said before, you can implement whatever you want here, whatever makes sense for the VNF you want to automate. So that's it. We built the charm. I mean, we prepared the charm. Now we are going to build it. So charm, build. So this is the source of your charm. It's good for you to keep it in a safe location in your developer environment, not in an ephemeral VM, because otherwise you will lose the source of your code. It happens another time. Because the build charm, it will be a heavier package because it includes all the software that you need for the layers. The source is just a few text files. Okay. So we have the charm built, and it's built in the builds directory. So we have actually it's charms, builds, simple, and that's the content. You will see that there's a reactive file, the actions file, the metadata, but there's also other files that include all the requirements of your proxy charm. And that's it. We have our charm ready. So now we need to include this in our VNF package. Let me see if I have something here. I will erase every reference to previous examples. Make sure that nothing is running. Okay. Okay. So let's see. I will get this template. It's just a simple package, VNF package, ready with cloud init and most of the things you already done this week. And I will go ahead and edit this file to add the BNF configuration part. So you should already be familiar with this. It's just a descriptor containing the connection points, the VDU, the VM flavor, the interface, management interface, very simple BNF, with a cloud init file that takes care of day 0. So this cloud init, let's see what it does. Actually, let's go into this cloud init. So it just providing a password which is called OSM for you. Okay, so that you can use it for logging in, and that Proxy Charm can use it as well. What else? A very important piece here that you have not used yet, but it was there, is the management interface. You see here, management interface includes a connection point, refers to a connection point. What do you think this will be used for? Any idea? You're specifying a connection point here for management. Yeah, so OSM will go there to run the charm. So it will instruct the UI environment to do so by providing the IP address of that connection point. So whenever, as soon as it instantiates the VMs, it goes and gets the IP address from the VM, the VM delivered to this connection point, and it sends it to the UI environment, so UI knows where to go to run the proxy charm. So it will SSH there to that connection point. So this is very important. You can have a per VDU proxy charm as well. That's there's another way of configuring that, which is very similar, but instead of using BNF configuration, use VDU configuration. Okay. So now we are going to add the important pieces to implement our charm. I will copy and paste all of this, and then we'll start going over it. Okay. I added this BNF configuration part to our descriptor. It instructs the OSM to use this charm, which should be included in the package, okay, in the charms folder. There should be a folder named simple. And then we will run day 1 primitives first. Day 1 primitives should, in the mandatory way, include this config primitive, which is a name that we should use, our reserved name, with the parameters that OSM will use, or you will use to connect to the BNF. So as I said before, you can use SSH keys here. We'll do that in this example, but you can eventually do that without referring a password. How we do it? Sorry. Okay. So then we'll have this other primitive. And you see here a line which is sequence 1 and sequence 2. This is the order of the primitives. Okay, so sequence 1 always needs to be the configuration primitive, because you need that information to log in. And then sequence 2 and beyond, you can use it for your own day 1 primitives. So we are running the primitive named touch with a parameter file name, and we will give a value to that. It needs to have a value, because otherwise it will be blank. That's the way we implemented our primitive. Okay, so day 1 is ready. These other slides go over this theory about every part. And then we will add, no, this is not it, the day 2 primitives, which for which we use config primitive section. Okay, so I'm going to go back, and this will be the same level of initial config primitives. Oops. Okay. So you see, we have initial config primitive providing the configuration it needs to log in, and the touch primitive automatically, and then we will be able to run a day2 primitive on demand, which is called touch as well, and we'll use the same action that was configured in our charm. We're almost ready. So now we just need to include in the charms folder, which is here, if I list this, is empty. So I need to copy the charm that we built to this folder. So now it should be there. There it is. It's just the complete folder. Let's validate the descriptor. For me, it's not going to work this way, I guess. I need to go to the DevOps folder, okay, and run this validation tool. Sorry. Okay, if the validation tool throws nothing, then we're fine. And now we go back to the home directory and just recompress the package, and we are ready. We have our VM package with a charm. So now I'm going to download the NSD as well. And finally, we are ready for instantiation. So I'm going to create the BNFD. Already exists. I'm going to delete that. Oops, sorry. There's a big monster. Okay. DNF. Okay, now I'm going to create a file that we just built so that you know that I'm not cheating. And an NSD. Okay, so we are ready for instantiation. As I was saying before, when you will see, if you don't speed up this deployment, it will take a while, and you will eventually get bored if you build a lot of charms. So you want this to be fast. And there are, as I said, two documented ways of accelerating the deployment of charms. One is by cloning an LXC image, so it's locally cached. But here we have a shared environment with many users, and it doesn't work that well. So we already use a second method, which is just configuring the model to run this APT mirror. So I configure this, okay? But it will not work. Do you know why it will not work? I said this before. I don't know if you listen. We don't have the model. That's right. We are running on a model called default. That's where proxy charms were deployed release 5 and back. But from release 6, every network service has its own model where it will contain its own set of charms. So more independency between network services. So we don't know the name of the model yet because we don't know the network service ID yet, and that's the name of the model. So what I do is I instantiate, and as soon as I instantiate, I switch to the model with UUSwitch, which is, this is the command that will switch us to any given model. And then I will configure this to speed up the configuration, okay? So let's see if I have a beam configured. I think I have the beam. Yes. It's called different. And I'm going to create this. Okay, I'm going to create the network service and immediately run these 2 lines that will switch to the model and reconfigure it. So if I run now UU status, which is the command that you should use to track for the status of charms, you will see waiting for machine. It's instantiating an LXC machine, a local one, where it will put our code, and that machine actually is the one that is going to connect to the VNF. It's not OSM. It's not a host. It's this dedicated LXC machine for every single VNF that you have. So it's waiting for machine. Eventually, it will start installing software in that machine. So let's wait a little bit. I think you cannot accelerate this with this method. We cannot accelerate this part because you need to instantiate the machine. But anyway, we got the machine already, and you see it's installing from this archive located in France. So it got our configuration, and it will be faster because otherwise it will go to the US and it takes more time. Okay, so here it is running this LXC machine. It's a container, a Linux container, and it's installing the software that our proxy charm needs. So there's some Python libraries that we need by default. For example, to give you an example, we need Paramico. We use Paramico to connect through SSH to the VMs. And of course, more libraries. So it's installing the libraries, setting up everything. And if you had any specific library, like Python requests, for example, for implementing a REST API interaction, or Ansible, so you will see that it's being installed here. Eventually, it will finish, and it will say, remote machine not ready yet, invalid IP address. Why is that? Because the network service has not started with the VMs yet, so it doesn't know where to connect to the proxy charm. So the proxy charm was installed, but it will not run until the VMs are ready, of course. So now it comes instantiation. So you will see since release 6 that as soon as you launch the network service, it will not start deploying the VMs yet. It will first take care of installing the charms, the LXC containers. It will then proceed to the instantiation, and as soon as the VMs are ready, it will start with the primitives, okay, running the primitives. So we'll see that now it's ready because now the VM provided the IP address. Actually, there is a command for that. If you want to know more about that, it's a uuconfig command, and you put the name of the application, and then you will see all the parameters that OSM shared with UU. For example, the IP address of the VM, which should match, of course, the IP address that is being used in OpenStack. I'm using tenant 38. So if we go to a topology, we have this machine here. And it has the address 24, which is not matching this one. Let's see what. 52. Because this is running in the default model, I guess. Let's see what happens. OSM bin list show. Okay, sorry, I was running tenant 1 actually. That's why the IP address is not matching. I'm just going to delete this. It was a previous sample. I'm going to switch to tenant 1. And here in the topology, you will see the VM that I just launched, and it has a 52 address, right? It matches the one that was given to Juju. So Juju knows where to connect to, and it's ready. It already ran the primitive. So let's see if that's true. How they put the... Sorry. 52. Okay. Okay, 52. Yes. OSM for you. List first touch. So it ran the primitive. Now, this is something that maybe because of this new bug, you will not be able to do, but it's just an example of how a day 2 primitive would run. So you specify enable and enable service, the DNF member index, which is 1, the action name you want to run, and the parameters. In this case, I will put, I don't know, a different name to the file, and run the action. Yeah, there is more than one. Yeah, this is the bug, actually. So there is another tenant already running this. I think I know what tenant it is. Otherwise, I will just leave it here for you to start with your. Charm. No, it's not here. No, it's not here. So sorry, I will mistake this file. But the thing is that you run this, and you have a new file there called whatever you are passing to your DNF. So this is the way you would implement any operation over your VNF. Automatically run operations, day 1. On-demand operations, day 2. It's just the way you define the code. Okay. Later, I will show you some examples that implement, for example, Sol2, which is a standard to configure a VNF using JSON files and REST API. Okay, so that's it. That's basic theory and example of charms. Any question? So I think it's a good time for a coffee break. And then we will continue and you will do everything yourself, by yourself. Okay? So let's break for how much? 15? 30? Wow, okay, 30 minutes. See you at 11. It's okay. Thank you. I will need to help you. Right?
Getting our back errors. I can't log in.
Take it easy, man. Okay, and now it's your turn. You need to go through all the process. You have the slides, right? Yeah, this one's okay. From slide 11, you start running. Creating your directories, setting the environment variables, and creating the charm and modifying the files. Okay. And if you need any help, let me know. You will need to create your beam again because this is a new instance of OSM. Okay. In the meantime, I'll try to take care of that bug I shared. No, HC, yeah, dot 14.
Because I think yesterday they were.
Yes. So you should use the shared instance, which is 172. Yeah, dot 14.
But
And
we
we
cannot so this we have to install in the local machine, right? So they should.
no, you can use the remote machine to install.
We can access that.
Yeah.
Through SSH.
Through SSH.
With the different
With the
accounts.
user and password. So yeah, you can log in into 172.21.248.14.
Okay.
Then you use, as user and password, use OSM, Hackfest, whatever, and then you start.
Okay. I thought that one was only for using it, not for
No, you can.
using the VM.